Welcome to Never Rewrite. I'm Isaac Askew.
Dustin Rea.
And I'm Jeffrey Sherman. And today we're going to talk briefly about programming techniques that nobody does anymore because they don't make sense. And so I'm going to explain bit masking, which is a
Mhm.
thing that was on its way out when I started my career, and which Isaac and Dustin, being slightly younger than me, have never even heard of because it's a crazy thing that people don't do anymore. So, briefly, a bit mask is the idea of packing multiple flags inside a byte. So if you have a bit, right, you've got a boolean, it's a true false value, and you can have
Mhm.
all the booleans you want. But back in the day when memory was expensive, you'd be like, oh, well, instead of using one boolean for one value, I'm going to use one byte and I'm going to have 8 booleans in it because I've got all these bits. And so this was a thing. And you would have to shift the bits in and out, and you would get these masks, which would be numbers that would zero out all the bits that you didn't care about. So you could see, is this one bit, is it on or not? And nobody does it anymore because, dear God, my friends, if the cognitive load of thinking about bits and bit masks is higher than the cost of ever running an inefficient piece of software. And yet, I have still seen people bit masking even into 2020 in cases that there are, so if you're doing race car type software, it makes sense. But if you're not even doing race car type software where being the fastest matters, people are still like, oh well, this is more efficient, I'm going to pack these bits in.
Hmm.
And do you know what you said? If somebody came to you and was like, all right, I've got this thing, it's super efficient, I've got all these I've got, it's Java, and ints are 4 bytes, and I have 64 flags packed into this one data field because I'm saving space in the database.
Mhm.
I feel like you'd have a strong opinion on that.
Well, so we're talking about like an integer like 100,100, and that would be a true false false, true false false,
Yeah.
essentially. And we're just storing, and then you have to understand what that fourth one true referred to.
Yes.
Right.
Yes.
Yeah, that
That's
sounds
exactly what we're
pretty
talking about.
that sounds pretty annoying. I think in today's era, if you're still doing that, you must be really starved for hardware. Like if
Right.
you like, I don't imagine if you're building a fancy race car and you're trying to store some kind of optimized data somewhere on a flag like that. Why would you be that starved for hardware for if you're spending it on an expensive race car anyway?
Well, the expensive race car was a metaphor. The people who still do this are high frequency traders where the fastest software wins, and bitmasks are faster and more space efficient than um, other things. Like, for one
Right.
example, you could read a byte and you would get all 8 flags versus reading all 8 bits independently. So it's a more efficient way of packing the data in, and because bit shifting is like an assembly level instruction, it's faster. So
Hmm.
if you're in a rare case like, hey, I'm trading stocks and I'm doing it high frequency, so it matters that I'm fastest,
Hmm.
then it makes sense to still do this thing. But like back when I started, database disk was still very expensive,
Right.
and it would make sense if you've got a million rows, and by using a bitmask you could save 100 megabytes of your database disk. That was a
Yeah.
useful thing to do. But
I
today,
yeah, I see your point. I mean, the way you set it up is kind of interesting because it's like
hmm,
you're still saying it depends. It still could be a useful thing to do if the thing that you
Right.
care about is being the fastest in the world. Then
yes,
sure, fair enough. But in every other case, I can't imagine, like you were talking about, the overhead of trying to remember which. Oh, we don't even know how large this int is. So I'll just give an example of a 6-digit one, but remembering which goes to which, in modern software, that does not need to work that fast, or we want it to work fast, but we don't care that it's like 1/100th of a millisecond faster than competition or something like that. Then,
Right.
Nanoseconds, my friends.
What I'm hearing is that efficiency for the sake of efficiency is not inherently good, right? Like
Yeah.
it's not really truly efficient if what you're optimizing for is storage. When back in the day storage was very expensive, then it makes sense. But in today's times, we're not, that's not what we're optimizing for. We're more optimizing for like engineering time. But so I think what you're saying is there are cases where if you need it, then it is valuable. But efficiency for the sake of efficiency is not inherently valuable.
Yeah, I imagine my client would love to log in quickly to their website, but it doesn't need to be so quick that I should rewrite the backend login in assembly, right?
Right.
Yes.
Right.
So, right. The marginal gain.
Right. I'm totally game for that. So, any other antiquated ideologies, or at least it depends antiquated ideologies?
Well, I thought we could do a whole series of these where we can talk very briefly about one antiquated thing that people don't do anymore, like bit masking.
Yeah,
so
I definitely have one for next time that we can do.
Okay.
That's great. I like that idea. And it's short like this. Yeah.
All right. Well, thank you all for listening. I'm Jeffrey Sherman.
Dustin Rea.
And I'm Isaac Askew, and this is Never Rewrite.